So what I learned from 3 years sciencing the crap out of DevOps. What I'm going to talk about here, firstly, how to make your data suck less. Surveys can be really terrible, and we're going to talk about how you can make surveys actually good. How to rub the science on things. I've learned a lot about how to rub the science on things from this person, my co-partner, Dr. Nicole Forsgren. So she and I and Jean Kim have been working on the State of DevOps report for the last few years. She is a statistician, or as we now call it, a data scientist. And I'm going to talk about stats. Everything I learned from stats, I learned from her. She knows much more than me, so don't ask me awkward questions about stats because I won't be able to answer them, but do follow her on Twitter and feel free to ask her questions. And then we're going to talk about the results, what we found, interesting things, weird things, particularly things about continuous delivery and management. So before I start, it's great to be in London. Continuous delivery basically it came out of London, came from a bunch of us working at ThoughtWorks, me and Dave Farley obviously, but also people like Chris Reed and Dan North, Sam Newman, Rolf Russell, and a whole group of us actually who are working on a bunch of projects here in London. So it's one of those things that really is came out of London, but also joined up at the same time as a lot of other things that were going on in Silicon Valley, continuous deployment, 10 deploys a day, out of Netflix, but it's a real pleasure to be here, so thanks very much for having me here. So, who here thinks surveys are shit? Fair enough. Who here loves the data from their log files? Who's seen shit data in your log files? Right, so surveys aren't the only source of terrible data. Bad data can come from anywhere, and part of what I want to talk about today is how you separate the good data from the bad data. Fundamentally, what surveys that are doing a good job are trying to do is measure things. And the way we measure things in surveys, the way that you measure things in science is you have a measuring instrument, like a thermometer. Now, we can't do that with feelings or impressions or psychological characteristics. So what we do is we create something called a latent construct. And a latent construct is a way to measure things that aren't as tangible as the physical things that we measure in the physical sciences. So what we use is something called psychometrics. Psychometrics is how you measure psychological things. It is a science in its own right. And we use psychometrics to make our survey data good in the sense that it gives us some level of assurance that it's telling us what we think it is and not things that we don't think it is. So there's a whole bunch of statistical analysis you have to do in order to do psychometrics. So firstly, you've got to create constructs. Constructs are basically sets of questions that represent, when you actually measure, a latent variable. We want to put some research in to make sure that we're using constructs that are valid, that are in the literature. So if you go and look at the literature, what you'll find is a bunch of people have done research before, and they found constructs that have been shown to be valid through statistical analysis. So wherever possible, we use constructs that have been previously validated and peer reviewed. And they're based on theory. What you're always trying to do when you're putting together a good survey is have a theory and have hypotheses. Because you'll get data, but it's impossible to interpret the data unless you have a theory or a set of hypotheses about what you're trying to discover. And we'll see an example of that a bit later on. You want to word them very precisely. One of the things that we're trying to do is establish validity. And there's these ideas of divergent and convergent validity. Of discriminant and convergent validity. Discriminant validity is making sure that your thing is isn't measuring something else, so that you're not measuring something unrelated as well as what you're trying to measure. Convergent is that you're measuring what you think you're measuring, not something else. So they're kind of two sides of the same coin, false positives and false negatives, if you like. And then reliability is making sure that people are interpreting the question in the way that you mean that you mean it to be interpreted. And so there's a whole variety of statistical analysis that you can do to make sure that your constructs are valid. And so putting in the effort to actually make sure that your constructs are based on theory and definition, and that when you get the results back, you actually validate that they are reliable and that you've got these tests in place is a very important part of this, and a lot of work has gone into that over the years, and there's a lot of research behind how you do that in an effective way. So let's take an example. I'm just going to get some water at this point. So one important example is culture. So we all know that culture is important, right? But what is culture? It's one of those things that's intangible by definition. But we want to measure it because we want to test the hypothesis that culture is important for IT performance, for organizational performance. So we've got to create a construct. And that construct's got to be based on theory. So what kind of culture? There's lots of different theories about how culture impacts various things and how culture has been measured in the literature over the years, particularly around things like national identity and norms, adaptive culture, value learning. What we used in the State of DevOps report is this theory of culture from a guy called Ron Westrum. So Ron Westrum is a sociologist who has been studying safety outcomes in healthcare and aviation, which are fields where when things go wrong, people die. So culture is super important in this context. And he made this typology. And the typology is based on information flow. So the idea is that this typology predicts information flow, and information flow predicts safety outcomes in these fields. Who's seen me talk about this before, by the way? Oh, good. So I'll go into a little bit of detail on this then. What he found is that you can probably work out where you fall on this map. There's 6 axes. One axis is the level of cooperation between different parts of the organization, different people within the organization. How we deal with messengers. Messengers are people who bring bad news. Do we train messengers? Are they ignored? Or are messengers shot? Who's been in an organization where nobody wants to report the bad news to the management? Right. Messengers are shot. So what you see in high-performance organizations is not just that messengers are taken notice of, but that people actually train messengers. One of my favorite stories about culture transformation is the story of Numi, which was a car plant in Fremont, about 30 minutes from where I live in California. That was a joint venture between General Motors and Toyota. I'm not going to tell the whole story now because I don't have time, but you've got a bunch of people working in GM, which was a very pathological culture, essentially. And they went to work at Toyota to learn the Toyota production system. And the Japanese managers at Toyota would say to the GM managers, you know, how's everything going? And the GM managers would be like, no problem. Is everything okay? No problem. And then eventually the Japanese managers got really frustrated and they said, no problem is a problem. If you're telling me no problem, that means that, I mean, we all know things are going wrong, right? So fundamentally, if you're telling me there's no problem, you're lying to me. And then I can't fix the problem. And being able to fix the problem and consistently working to identify and fix problems and improve is basically the characteristic of high-performing organizations. High-performing organizations are not organizations that don't have problems, because every organization has problems. The question is, are we working to identify them and fix them and get better all the time? And the high-performance companies are the ones that do that at a higher rate than the other companies. They're always working to get better. So actually making sure that you cultivate people who bring you bad news, and then based on that you do something about it and fix it, is really important. One of the things in DevOps that's a really big deal is this idea of blameless postmortems. And so John Allspaw, who's I think CTO now at Etsy, came from Flickr, he talks a lot about investigations into accidents. When something goes wrong, we do an investigation, and what we don't want is to find out that the investigation ends in, you know, it was Matt's fault, because that doesn't tell us anything. The interesting question is, why did Matt make that mistake? What information did Matt not have, or what tools did he not have available to him that meant that he made the mistake that he did, and what can we do to give him better information in the future? If you take somebody who makes a mistake and you fire them, what's going to happen is the next person who comes along is going to end up making the same mistake because you haven't done anything to improve the system that they're working in. Typically, we're working in complex adaptive systems in IT. And that's why actually there's a big link between aviation and healthcare and what goes on in IT, because they're both what Allspaw calls high-tempo, high-consequence environments where we're overwhelmed with data and it's very easy for things to go wrong. And in complex adaptive systems, we never have enough information, especially not management. And we can never anticipate the consequences of our actions. There's always side effects, unpredictable consequences. And it's very easy when you're looking back. There's this fundamental asymmetry to complex systems. When something goes wrong, it's very easy to look back and see the chain of events that led back to the initial contributing factors. It's very hard looking forward when you're about to do something to predict the enormous kind of network of events that's going to lead off it and the interactions. So in complex adaptive systems, failure is inherent in the system. You're going to have failures. It's inevitable in a complex adaptive system. The question is, how do we create information, and how do we gather information, and how do we interpret it in such a way that we can reduce the negative consequences of accidents, and so we can become better informed about them? So when something goes wrong, you should never be asking, whose fault was it, and can we fire them, please? What we should be asking is, why did that person not have sufficient information, and how can we give them better information and better tools so that we don't make the same mistake again, which is what this piece is around. Failure leads to scapegoating, failure leads to justice, failure leads to inquiry. And then bridging between different parts of the organisation, how we deal with risks and responsibilities. And then perhaps the most interesting thing about this is novelty. How do we deal with novelty? Is it implemented? Does it lead to problems, scope creep? Or is it crushed? It's my favourite part of the model. So, this seems pretty plausible as something which might have an impact on IT performance and organisation performance. And that fundamentally is what the State of DevOps report is about. It's about how can we measure IT performance, organisation performance, what are the factors that impact them, how can we measure them and actually prove or disprove whether that's the case. So it's very important to us to try and measure this. What you want to do when you want to measure something like this, like culture, is use strong statements with clear language that when you read the statement, you can strongly agree with it or strongly disagree with it. So it should be a strongly worded statement that you can very easily agree with or disagree with. That's what you want when you write this out in a question form for a survey. So try writing a question yourself. You've got some paper. I'll just give you a minute to try and write a question for one of these different axes that you might use in a survey. Okay, so here are the questions we actually ended up asking. And what we found when we evaluated the data at the other end is that they actually were both valid and reliable questions. So they were good questions to ask, it turned out, because when we did the statistical analysis, we did that discrimination analysis and reliability analysis, they did something called, they loaded together, which I'll explain a bit later. And furthermore, we found that they were predictive of both IT performance and organisation performance. And the way we actually asked it on the State of DevOps report, we've asked it again this year, is like this. This is called a Likert type scale. So what you end up with when you get the data is a number from 1 to 7. So this is what it actually looks like. And based on this, you can actually get numerical data from each one of these things. But this is, Likert type scales are one of the bedrocks of psychometrics. One of the other things that we asked as part of the survey is questions about how you find out about failures in your production environment. So again, these are strongly worded statements that you can either strongly agree with or strongly disagree with. It's another Likert type scale. And what we noticed is they didn't load together. So what do I mean by load? So when you're building a survey, what you do is you take these questions and write them on 3x5 cards, and then you give them to people, and people bucket them. They say, are these things related or are they not related? And things that load together are things that are related to each other. You put them in the same bucket. So if things load together, it means that conceptually they're related to each other, and numerically when you measure them, you can do statistical analysis to evaluate whether they are in fact related to each other because they move together in results. And what we found is that these things didn't load together. So when we did the statistical analysis, they didn't load together. And so again, the stats doesn't tell you why. You have to have a hypothesis as to why they didn't load together. And so I've given you the answer. Can you, well, I haven't actually. What was our hypothesis? What did we do when we discovered these things didn't actually all load together? They weren't all conceptually related to each other. Any ideas? How are these things not related to each other? Huh? You can have failures without monitoring. That actually ended up not being our hypothesis. What we ended up hypothesizing was that there was two categories here. There was notification from outside the team and notification from inside the team. So this is where the network operations center or customers tells the team that something's wrong, whereas these are the things that the teams are measuring from inside. And what we found is that that was actually true. When we looked at the data, these two things loaded together and these three things loaded together. So this is an example of, something doesn't load, you're like, WTF, that's bizarre. And then you come back with a hypothesis and test the hypothesis against the data, and you find that actually, if you break it into these two categories, these things individually do load. And then what's interesting is these things predicted IT performance more highly than this did. So when the team actually pays attention to the data on what's going on in production, that predicts higher IT performance than when teams are notified by outside other parts of the organization. So again, really interesting example. If you've got a theory, you gather some data, there's a negative result, you're like, okay, well, let's come up with another hypothesis. You test the result, and not only is the results statistically valid, but we actually have something interesting to say, which is that if your team gathers the data and analyzes itself, you will have higher performance in IT than if you rely on other people to tell you when things go wrong. We have other kinds of tests that we do to make sure that the data is good. So we kind of ignore very early responders and very late responders. We look at survey drop-off rates. We have statistical tests to look for bias. We do something called common method variance. I have no idea what that is, but again, you can ask Nicole or look it up on Google. She basically spends about 3 weeks just in SPSS, just analysing data and doing all this stuff. And this is standard stuff that you do if you're a statistician. So now we can actually look at the data. Now you've got some idea of the theory behind what we were trying to do. So the first thing we found in the 2014 State of DevOps report, which is the first one where we actually really had rigorous stats in place to do it, is that IT performance matters. We have been told for years that IT performance isn't important. David Carr famously wrote an article for Harvard Business Review that says IT doesn't matter, that it can't consistently provide you with a competitive advantage. He's not saying that it can't provide you with a temporary competitive advantage, it can, but what he's saying is that people will just keep catching up to you. So fundamentally, according to David Carr, IT is just plumbing. You can't create competitive advantage through better plumbing because plumbing is fundamentally commoditized. So we beg to differ. And what we found out is that's not actually true because, frankly, the world has changed since David Carr was writing that. And now every organization in the world is moving to digital, including the government. So one of my 3 jobs is working for the US government at the moment, helping to build digital services. So we have a standardized measure of organizational performance, which is profitability, market share, and productivity. And again, that's standard in the literature. There's been lots of work done on those 3 measures, profitability, market share, and productivity as a measure of organizational performance. And what we found is that IT performance matters. We were able to divide the respondents up into 3 groups of high, medium, and low performers in a statistically valid way. And what we found is that the high performers were twice as likely to exceed their profitability, market share, and productivity goals as the low performers. So IT performance does actually matter. And I'll talk about how we measured IT performance in just a minute, because that's interesting in its own right. In terms of the top predictors of organizational performance, what do you think the top predictor of organizational performance was? Which factor? Huh?
Market share.
Market share. So what predicts market share? What predicts market share, profitability, and productivity? What characteristic of your organization predicts having really great organizational performance?
Product market fit.
Huh?
Product market fit.
Product market fit. So I'd say that was also a measure rather than a predictor, but it's definitely important. Employee engagement, that's pretty much bang on. Who was it who said that? Yeah. So it turned out these were the questions that had the most strongly predicted organizational performance. Net promoter score for your organization, job satisfaction, whether your job makes good use of your skills and abilities, whether you have the tools and resources to do your job well, and then having a feedback loop from production to your business decision-making process. So having a feedback loop and then job satisfaction. And we've kind of known this for years, that job satisfaction is important, but it's really striking to see it in the data. We have like 8 pages of things we measure, everything from how you do continuous integration, to management, to test automation, all kinds of, we measure so many different things in this survey, and we changed it over the years. And consistently, what we found out is job satisfaction is the biggest predictor of organizational performance. It's so important, it overwhelms all the other factors. What predicts organizational performance? What predicts job satisfaction? Anyone care to guess? Huh? Salary. So that's really interesting because who's read Daniel Pink's work? Drive.
Autonomy, mastery, and purpose.
Autonomy, mastery, and purpose. Right. So what Daniel Pink says that in jobs which are routine, where the tasks that you're performing are algorithmic, where there's a recipe you can follow, salary is a big predictor of performance. But in jobs where you need problem-solving skills, where you're fundamentally using heuristics in order to achieve your goals, that's not what you need. What you need is autonomy, mastery, and purpose. And so in all the things we measured, the thing that most strongly predicted job satisfaction was culture. The answers to these questions predicted organizational performance, predicted job satisfaction, and that predicted organizational performance. And by the way, job satisfaction also predicted culture. So there's a positive self-reinforcing cycle between job satisfaction and culture, which has a positive impact on job satisfaction, which has a positive impact on culture. So those things are mutually reinforcing. And then very recently, a few weeks ago, Google published the work that it had done on looking at what makes effective teams in Google. Has anyone seen this? Yeah, tons of you, right? So it's fascinating. So they had all these hypotheses about how you make a high-performing team in Google. You know, you're going to get 3 front-end people and a couple of back-end people and fire all the project managers and yay. And that, unsurprisingly, didn't work. I mean, Google fired all their managers and then everything went wrong. And they're like, oh, maybe we do need management after all. And they spent years actually studying how you build high-performing teams. And what they found is that the most important factor is psychological safety. Team members feeling safe to take risks and to be vulnerable in front of each other. And if you look at what Westrum's talking about, the things that predict high performance, good safety outcomes, you know, this whole model is premised on the idea of creating safety. How do you create safety? And these factors that help you create safe environments. And safe environments are ones where you get novelty. That was the other really interesting thing. What we're looking at is IT performance, your ability to create high throughput and high stability, very high performing systems. Safety is really important. The same factors that predict safety also predict your ability to innovate, which is fascinating and it exactly reflects what the Google data tells us, which is that the most important factor is building teams where people feel psychologically safe. And then you're much more likely to take risks because you're not just worried about covering your ass the whole time in case things go wrong. Because you know that when things go wrong, you're not going to be fired. Instead, we're going to work out why it went wrong and make things better. And the team's involved in that, and you know they have autonomy and the ability to pursue mastery. And then all these other things as well, which again reflects, I think, a lot of Daniel Pink's work. So how do we measure IT performance? Well, that was pretty interesting in its own right. And we tried measuring a bunch of things. What we ended up with is these set of metrics. And we validated that they do actually load together. What you've got here is actually 2 different kinds of things. So the top 2 measures are throughput measures. Lead time for changes from version control to production. So how long does it take us to take a change from checking it into version control to having version of the software with that change in production? Release frequency, how frequently do we release? And then 2 stability measures. Time to restore service, so when something goes wrong, how quickly can we get it up and running again? and then change fail rate. When you put a change into production, what percentage of the time does it fail? Or actually, what we asked is, what percentage of the time does it fail, or do you have to hotfix it? Because as we know, nothing ever fails, it just gets hotfixed. So what we found, which was fascinating, and I can't emphasize this enough, it's like the most important thing that you could possibly take away from today, is that the companies that are high performers do better on both of these things. We are so used to thinking that there's a trade-off, that if you go faster, you are going to break things. That is not true. The companies that do better on throughput also do better on stability. And this is pervasive. I see it all the time. There's, people talking about DevOps. Oh, well, these companies that do it, they don't actually have to worry about what they're doing because if something breaks, it doesn't matter. That's actually not true. What you find is the companies that put a lot of effort into making things faster, also they make things better and more safe. Even who's come across Gartner's bimodal IT? Right, so there's many things wrong with bimodal IT, and I've got a blog post that I'm kind of been working on for weeks now, which I'm going to publish, where I basically just eviscerate it. But the thing that I hate most about it is that it rests on this false premise, which is that fundamentally, if you go fast, that's okay, but that's going to compromise safety. So your systems of record, we shouldn't adopt agile methods in DevOps. And that's fundamentally wrong. You can absolutely apply these things because fundamentally what DevOps and continuous delivery are about are getting better. And what you're saying is we don't want to get better. These systems, fundamentally we're still going to work in the dark ages with manual configuration management and no test automation because we don't want to get better. Because if we get better, we might change things and then things might break. Which is, A, it's fundamentally flawed, but also the data shows it's not true. The high performers do better at throughput and they do better at stability. The same things that help you produce higher throughput, like configuration management, deployment and test automation, those actually help you build more reliable systems as well. And the data very clearly reflects that. What are the things that have the highest correlation with IT performance? So, using version control, turns out, is very important. Who's worked on a team where they don't use version control? Isn't that terrible? Oh my God. I once worked at an investment bank where there's a team building all these models and they just weren't using version control. They would just copy Perl scripts to each other's workstations. You're like, there's hundreds of millions of dollars of people's pension funds, being basically managed by people SCPing like Perl scripts to each other. So yeah, it turns out version control is important. Who knew? What's fascinating is that actually it's more important to have your application configuration and system configuration in version control than it is to have your code in version control, which is a surprise. But basically, this is what enables you to reproduce the state of production when things go wrong. If you have a failure in production, if you're in a disaster recovery situation, what you want to be able to do is restore service as fast as possible. And the only way you can do that in a repeatable, deterministic way is if you can restore the configuration of production from version control in a fully automated way. If you're having to log in and change things and edit things, you can't do that. You're going to end up with high levels of variability because people are human and it turns out humans make mistakes. So that's very important. And again, this is one of these things that you can kind of intuitively see. Anyone who's worked on doing this, you can intuitively see how that increases throughput and stability. So it's very good at improving stability in terms of time to restore service because it makes it much easier to restore service when something goes wrong because you can just restore from a known good state of the system. But also, it allows you to increase throughput because this is the mechanism that allows you to create testing environments on demand rather than waiting a month for someone to manually configure the testing environment. Whoops. Yay. Who's actually been, who works at an organization where it takes more than 2 weeks to get a testing environment? Yeah, okay, loads of you. So 2016, we shouldn't be doing that. We should be able to self-service test environments on demand. And that's either a problem with your infrastructure or it's a problem with your architecture. But it's a problem with one of those two things, or possibly both of them. And it's something that actually needs to be addressed. People are like, well, we can't do that because of your architecture. And the response to that is, well, then you've got to find a way to improve your architecture. There should be no excuses. We've shown this stuff can be done with mainframes. with all kinds of very complex, hairy systems. I spent the last 5 years consulting in big Fortune 500 companies. It can be done. It's hard. It's expensive, but it can be done. We can always get better. Getting failure alerts from logging and monitoring systems rather than from, say, Twitter. And then two things that are very dear to my heart. I've been banging on about the importance of continuous integration for longer than I can remember, like over 10 years. And I've been saying, continuous integration is really important. And people have taken on that message that continuous integration is important, and everyone these days says they're doing continuous integration. But what I discovered happened is that people have redefined continuous integration so that they can say that they're doing it. Which turned out to be a very popular strategy in IT in general, is to take the thing that everyone wants you to do and redefine it so that you can say that you're already doing it. So who in this room is working on a team that's doing continuous integration? Put your hands up. Oh, everyone, brilliant. Keep your hands up, keep your hands up, keep your hands up. All right, put your hands down unless all the developers on your teams are checking into trunk to master to mainline at least once a day. If they're working on feature branches that do not get merged into master, into trunk at least once a day, put your hands down, otherwise keep them up. So long-lived feature branches, that's not trunk-based development. And then if the tests, when they fail, are not typically fixed and green again within 10 minutes, put your hands down. Okay, so this is actually an astonishingly high number. I think that's the biggest proportion of hands I've ever seen. So well done to all of you people. Normally what happens is I ask those two questions and there's like 2 hands left up in the room, and I'm like, continuous integration is not running Jenkins against your feature branches and then ignoring the build when it goes red. It's a practice, not a tool, and a mindset, and it's the practice of everyone working in small increments off master, off trunk, and then actually fixing the build when it goes red. So, I've been through so much on this. Like in 2005, 2004, when we were talking about this, people said, well, continuous integration works on your small team, but it can't possibly work in big teams. And then now I have slides from Google with more than 10,000 developers all working off trunk in Perforce, and I show these slides, and I have people coming up to me at the end saying, well, I know continuous integration works at Google, but can it work on my small team? And I'm like, it's good to have these problems. And then people saying, well, I'm doing continuous integration. I have a bunch of feature branches on GitHub that get merged once a week, and that makes me sad. So I asked these questions, and it turns out that these things have a very high correlation with IT performance. So not only am I right, but I have data that says I'm right. And this is why I love surveys, because they're such a powerful source of confirmation bias. The other thing that's really important is this thing. This is the DevOps thing. When development and operations teams interact, the outcome is generally win-win. So rather than people finger-pointing and blaming each other when things go wrong, they actually work together. And when things go wrong particularly, this is when we find out what people are made of. Anyone can be friends when things are going well. The question is, what happens when things go wrong? Can we actually work together, or do we, does the facade break down and we start, throwing rocks at each other? So in terms of the top predictors of IT performance, this was the biggest shocker, actually, this thing at the top. And I'm going to come back to this in a minute. But basically, change approval processes, this is a big shocker. Version controlling, proactive monitoring, high trust organizational culture, which we've already talked about, and the win-win relationship between dev and ops. So this is 2014. I'm going to move to what we discovered last year in 2015. What we did in 2015 is we did some more powerful stats, and we use something called a structured equation model. And the structured equation model is interesting because it actually allows you to move beyond correlation and into the realm of prediction. So who's familiar with the idea of correlation? Right, so correlation is when two things move together, but you've got to be very careful about correlation. I have kids, my kids get vaccines. In California, there's a whole movement of people who are so well off that they've completely lost their minds, and they've decided that vaccination is actually the work of the devil, and it's a big plot by Big Pharma to give all our kids autism. And so they have all these graphs that show that as vaccination has increased, so has the incidence of autism. But it's very easy to debunk this because you can also produce a graph showing that as sales of organic food have increased, so has the incidence of autism. So correlation lets you make up whatever you want. I mean, you can actually show that the incidence of pool deaths is correlated with films by Nick Cage. So Nicolas Cage films are correlated with pool deaths. So make of that what you will. But it's important to move beyond correlation to prediction, and this is what structured equation modeling lets you do. Don't ask me how it does that. I have no idea. Ask Nicole. But basically what happens is I draw a diagram like this, and Nicole plops it into a tool that does structured equation modeling, and then she comes out with a lot of numbers which basically show the reliability of the prediction. So R squared is a measure of reliability that this thing actually does predict this thing, and then this is the strength of the prediction. And so what you can see is that the use of version control and test automation and deployment automation predict this thing. And this is a construct that is composed of all of these things together. So being able to create intermediate constructs, I basically said, let's combine these things into one thing, and I'm going to call that thing continuous delivery. So this is my theory building. So I love this. Like, basically, I had some beers, and then at about 10 o'clock at night, I drew this on a piece of paper. I took a picture of it with my phone. I emailed it to Nicole. Nicole spent a bunch of time in a statistical analysis tool, and she's like, yep, you're right, and these are the numbers. And I'm like, fuck yeah. And so what we can see is that this is something which...
Those correlation coefficients are quite low.
Yeah, some of them are higher than others, but all of them are statistically valid. So you've got to look at 0.05 is the lowest limit. Anything below 0.05 is not considered meaningful. So we eliminate everything that's below 0.5. I can't remember what the R squared is. But anyway, what we can see is that test automation is an important component of continuous delivery. Continuous integration is an important component. Deployment automation is perhaps the least important, which is, I don't know, maybe surprising, or maybe we measured it wrongly. Version control is kind of somewhere in the middle there. And then continuous delivery is strongly predictive of IT performance, so it has a big impact on IT performance. It also has a strong negative impact on change failure rate. And then perhaps, and then it has a very strong negative impact on deployment pain. So continuous delivery makes deployment pain, reduces deployment pain. And then perhaps what's most interesting about last year is it also has a significant negative impact on burnout of your teams. So looking at burnout was one of the things that we did last year, and that was really interesting. And then organizational culture, measured using Westrum, has a really strong negative impact on burnout, which you also might expect, but again, it's interesting to see it in the data. And a noticeable but relatively small impact on IT performance, and a decent impact on organizational performance, and we can see that IT performance predicts organizational performance. So this is a really, this is a really interesting bit of analysis, and this was actually published. So we had this published in a journal about a month ago. It's been peer-reviewed, so we can now say, this is proper peer-reviewed research that demonstrates the impacts of continuous delivery on all these different factors. So yeah, and there's the reference where you can go and download the paper, which is very long and filled with unintelligible academic speak that Nicole wrote and a bunch of pictures that I drew. So, some surprises. What's not strongly correlated with IT performance? Which of these things, who thinks that third-party scripts for configuration management, so this is all configuration management strategies. Who thinks that third-party scripts predict IT performance? No one? Good. How about homegrown scripts? Okay. How about commercial configuration management tools? How about open source? How about golden images? How about manual configuration management? Okay. You're mainly wrong. Which is a good sign, right? I mean, if you're right all the time, then it's probably just confirmation bias. So what we found is that third-party scripts, homegrown scripts, golden images, manual configuration management have a very small or even negative correlation with IT performance. Open source has a strong positive correlation with IT performance. Using commercial configuration management tools has literally zero correlation with IT performance. So sorry to all the vendors in the room, but there's literally no point, according to our data, in using commercial configuration management tools. Let's look at test practices.
Have you tried measuring organization with absolutely no configuration management to just compare? It's easy to say no correlation, but if you compare with something that would say negative, if you don't do it at all, then you're doomed. Then obviously,
right. Yeah, it might be better than.
It's all relative.
Yeah. So this, I mean, what this tells you is that this is no better than doing nothing, right? So you would have to ask Nicole exactly how she did the analysis. But basically, these are checkboxes, so they're 1-0. It's no better than doing nothing. Yeah, I know, right? So yeah, that's my investment advice for you. Stocks may go up as well as down as well as up. I'm not liable for any blah, blah, blah. How about effective test practices? Which of these things do you think are important in terms of IT performance? Or I should ask, which things do you think are not important? So what we found out, and no real surprises here, well actually one surprise. So we found out that, actually a few surprises, things that I was expecting to happen, but they're still surprising to some people maybe. So it's important for developers to create and maintain acceptance tests. So it's not enough to have acceptance tests, they've got to be created and maintained by developers. Now, I had a hypothesis about why this is the case, which is why I asked this question. And my hypothesis is that when testers create and maintain the tests, developers don't care about them. And actually, that there's a feedback loop wherein, when testers write the tests, it forces them to write code that is more testable. So this is one of the things, so who practices TDD? Who works on a team where you write the tests before you write the code, and then the code makes the test pass, and you actually press a button and see that? Okay, so that's actually pretty standard. I typically find about 25% of people all over the world give that answer, which is depressing to me, actually, because I went to Silicon Valley filled with hopes and dreams that it was a better place full of amazing technical practices and brilliant people. And I found that people there aren't any better than anywhere else. They've just got much better PR. And it's about the same there, like 25% of people doing TDD. It's the lost XP practice. And I think the important thing about TDD is not that it gives you a bunch of automated tests. That's a nice byproduct of TDD.
Did you test TDD? Did you say, does it make a difference if I write the test first or if I write the test second?
No, we actually didn't. And actually, that's a really good point. We totally should do that. I've just missed it for this year because we've just put it out yesterday. Shit. Well, there's always next year. Who writes the tests before they write the code that makes the test pass? Damn it. Okay. But my theory as to why that's important is because it forces developers to create software that's easy to test. The important thing about TDD is not the tests. It's the fact that it forces you to write your code in a testable way, where it's nicely encapsulated and componentized and loosely coupled. So writing the test first exerts an architectural force on your code that makes it more testable, and then that makes it easier to maintain the tests. Who has contemplated deleting all their tests because they're too expensive to maintain? Right, so in my opinion, that's a factor. That's because they're not written TDD, because maintaining tests that weren't written TDD is very expensive because it's very hard to test the code because there was no force acting on the code to make it more testable. So that was my hypothesis. And so that was actually shown by the data. When testers or when an outsourcing company creates and maintains tests, it actually is not effective. You need the developers to do it because that's how you make sure that your code is actually testable, which is how you make sure that your tests are actually maintainable in an economic fashion. This is important. When the test pass, you actually have some level of confidence the software is releasable, that it's actually meaningful rather than a bunch of tests that always pass. Is Ivan Moore around today, by any chance? Oh, that's a shame. Well, Ivan Moore's a a guy who lives in London who wrote a program called Jester, which randomly mutates your code just by literally randomly mutating your code and sees if the tests actually fail or not. And what he found is a surprising amount of tests just always pass. So that's the thing. Test failures are likely to indicate a real defect. So this is the false negative, false positives, false negatives, basically. Making sure that developers can actually fix the acceptance tests easily, because, for example, they can run them rather than having to have very expensive acceptance testing software that you can't afford to buy the developers' licenses for. Developers, so this is interesting. Having developers share a common pool of test servers to reproduce failures is positively correlated. Developers creating on-demand test environments is not positively correlated. I have no idea why that is. It's just one of those things. Who knows? But then developers using their own development environments to reproduce test failures is important. So I said I'd talk about change management. I'm going to talk about change management. These are the questions we asked about change management. Do you use a change advisory board or some other external body who must say yes or no to your changes before you push them to production? Whether you do that just for high-risk changes, whether you have no change approval process, or whether you rely on peer review, meaning pair programming or developer code review. And what we found is to make this load, and it is highly predictive once it loads, we had to reverse code this. So having an external board was negatively correlated with IT performance. And this fell out. This didn't load at all. And our hypothesis is that this construct was just too, it was trying to measure a bunch of different things. It wasn't precise enough a question. So this thing fell out. This is like the discrimination thing. And then these two things plus this thing reverse coded predicts IT performance. So what this tells us is that change advisory boards don't work. In fact, they have a negative impact. And when you look at what we're measuring throughput and stability. I was immediately suspicious of this because that was too good to be true. So I'm like, okay, well, let's break this out and look at throughput and stability. And what we found is that this has a massive negative impact on throughput, which is exactly what you'd expect. Obviously, it makes things slower. So the interesting question is, what's the impact on stability? And the answer is, there is negligible positive impact on stability of using change advisory boards. They have negligible positive impact on stability, but they are very, very bad for throughput. So they slow things down massively and don't make things any safer, effectively. And what you want to be doing is, and again, actually no change approval process is better because at least you can move fast. And this is the best thing to be doing using pair programming or developer code review, developers checking each other's code, basically. And like intellectually, it's easy to see. Like I have a theory about why this is. I had a friend at ThoughtWorks who worked for a large European electronics manufacturing company, and they had a change review process where you would fill in a spreadsheet with 7 tabs and email it to a change manager in a different country, and the change manager had no idea what was written in the spreadsheet, and so they would phone up the developer and ask them a bunch of questions, and if they liked the answer to those questions, they would approve the change. You know, do you have a rollback process? Have you done all the testing? Blah, blah, blah. And the developers knew that the change manager had no idea what was written in the spreadsheet, so they would copy the last spreadsheet and then change a few of the boxes in the spreadsheet and email it through. And the change manager knew that the developer knew that the change managers had no idea what was written in the spreadsheet. So at this point, you have a process that I like to call risk management theatre. A performance designed to give the impression of effectively managing risk while actually demonstrably, according to the data, making things worse. And when you think about it, it can't possibly work. The idea that someone, all right, so who's a developer in this room? Who writes codes? All right, keep your hands up. Put your hands down if you've never had it happen to you that you've made a change that you thought couldn't possibly break anything and it's broken something. If that's never happened to you, put your hands down. Right, so you're all real developers. Okay, good. Yeah, I mean, you know, and we're the people who know the code base best of all. Like, no, we write the code, we know it so well. And we make these mistakes all the time. You push it into production, you're like, this CSS change can't possibly break anything. And then, you know, you push it into prod, and then the site goes down, and you're like, well, at least it wasn't me. And then, you know, like, half an hour later, like a bunch of very serious-looking people come to your desk and they're like, so, you know that change you made? So, yeah, you know, we do that kind of thing all the time. So what are the chances that someone who has no clue about the code base and doesn't even necessarily code could look at the changes and by inspection, understand the impact on the production system, particularly the impact of potentially hundreds of thousands of lines of changes by hundreds of developers over like a significant period of time. The only rational response, if you're in that position, is to say no. If I was in that position, I would say no, because it's the only rational thing to do. I mean, one of those changes is probably going to break something, so no. You can't make that change. Until someone who's your boss basically forces you to say yes. So it can't possibly work, doesn't work. Here's the data, yay. So I want to talk about management stuff a bit. I only have 10 minutes left, and I want to leave 5 minutes for questions, so I've got 3 minutes left, gosh. So work in process, managing work in process, having work in process limits. We know that's important, right? Everyone knows managing WIP's important. Turns out, correlation between WIP and IT performance is negligible. Oh noes. So this is one of these things where structured equation modeling came to the rescue. So we measured a bunch of different things, and then again, around the same time, about 11 o'clock at night after a few beers, I drew another diagram, took a picture, sent it to Nicole. She spent a bunch of time the next day in a structured equation modeling program. Turns out this model is valid. So WIP doesn't directly predict IT performance. But when you combine WIP limits with the use of visual displays to monitor quality, productivity, and work in process, and the use of application performance and infrastructure monitoring tools to make business decisions, which feed into this thing, which I'm calling lean management, that does predict IT performance. And if you take this away, the prediction is less strong. So this is one of these things where actually, again, shows the importance of having a theory and constructing a theory and then putting the theory into the model. And so these things together actually have a strong impact on IT performance, but this thing on its own does not. You have to combine this thing with these other things for it to be effective. And this is something we see all the time. You know, you can't just implement the practices piecemeal. The practices actually have to be implemented together, otherwise they don't work. So actually coming up with ideas about how you can combine things to have an impact on IT performance is part of what we're doing when we're modeling this stuff. So this year, in fact, yesterday, we launched the State of DevOps report again for this year. We're doing some new things this year. I have a theory that quality is also important. So we measured throughput and stability. I want to measure quality as well. All this stuff really, continuous delivery, lean management, all this stuff comes from basically the Toyota production system. And what Toyota did, which was so impressive, is they didn't just make cheaper cars. That would not have done it. What was impressive was that they made cars that were cheaper, they made them faster, and they made them higher quality. And that was what destroyed the US auto industry. It was the fact it wasn't a zero-sum game, it wasn't a trade-off, they changed the game. They changed the paradigm, and they were able to consistently improve the quality and reduce the costs and do it faster than other people, and they continue to outpace everyone else. And this is what's true with DevOps and continuous delivery as well. It's not a zero-sum game. We're actually changing the game and improving all of these things. And so my theory is that quality, continuous delivery is going to lead to improved quality. Our first problem is how do we measure quality? So we've got a whole bunch of different things that we're putting in to try and measure quality, and we'll see which ones actually load, if any of them do, with our other IT performance metrics. We want to look at security and compliance, the impact of these practices on security and compliance, and the impact of security and compliance on these practices. We're looking at test data, we're looking at some more lean practices, and obviously containers. So I'm a massive get off your lawn guy. I think containers is just Solaris zones, right? So yay. But we have a bunch of questions to see if that is actually important. And we launched it yesterday, so I actually wrote the platform in PHP because I'm a massive get off your lawn guy. And we launched it yesterday. I spent the whole of yesterday, I didn't sleep the night before last. I slept for 4 hours and then woke up after an anxiety dream about database deadlocks. I spent all of yesterday in front of New Relic just going, ah! And then I discovered that it was like I/O that was constraining the system, which is what it always is when you've got a database, so who knew? But yeah, please, this is the URL. Please go and take this survey. Please try and crash my terrible PHP software and prove that it's a terrible technology. Please do that by taking the software, not by red teaming my server. But please, if you do one thing, go and tweet this to everyone you know, get them to take the survey. We need this data. We put it into papers, we get it peer-reviewed, we publish it, and then we have real academic peer-reviewed data that shows that this stuff that we're talking about actually works in real life, which is really important in trying to get the industry to get better. We have a lot of things that we think are obvious. A lot of those things are not obvious. There's a great book called The Leprechauns of Software Engineering or something. I've blanked on the name of the guy who wrote it. Laurent Bossavy. So he wrote this great book called The Leprechauns of Software Engineering, which is basically debunking a bunch of stuff that people think is true but actually isn't. So testing with data is really important. And if the results don't surprise you, you're doing it wrong. We found some surprising stuff, and that's good because it proves that it's not just confirmation bias. Also, if everything surprises you, you're probably doing it wrong too. So some of the things should not surprise you. We can have it all. This idea that if you go faster, you break things is fundamentally wrong. The best organizations are those that are continually working to get better and that don't take no for an answer, or we can't make that work here for an answer. You can't, I mean, it's true, everyone is a special snowflake. You know, I give these talks, people are like, well, that's great, but it can't work here. And I'm like, you're right. These things I'm telling you can't work here. You are going to have to solve your own problems, and that's the only way you're going to get better is by solving your own problems, not doing what someone else tells you to. But what's not true is that you can't get better and that you can't find some way to improve your work environment and your solution and the systems you operate in and the cultures you operate in. And if there's one thing you should do every day, go into work, try and make things slightly better for the people around you. And if we all did that every day, the world would be a better place. Thank you very much. Questions? Yeah, a couple of questions, yes.
Hi, you were talking about biases. I'm a little curious about selection bias. I'm actually very much surprised that you got people to answer questions about the DevOps survey that actually said they didn't use source control. So.
Yeah, so selection bias is really important for those of you who aren't familiar with it. Selection bias basically says that the people who come and take your survey are not representative of the wider population. That's what selection bias is. And we're pretty certain that there's selection bias going on. The kind of people who would read my tweets, or the kind of people who would get the emails that we send out to the Puppet Labs people, and we've got like a whole bunch of sponsors this year, that's not going to reach the people who are working on mainframes in, you know, banks in Aberdeen. I mean, you know, a few of them maybe, but they're probably going to be a bit depressed, and it's just because they can't get another job, and they're like secretly wishing that everyone else would do this stuff, and like leaving copies of continuous delivery strategically placed next to the water cooler. So we're pretty sure selection bias is there. That's one of the reasons why I want everyone to tweet this, so we can get more people to take the survey. However, we had over the last 3 years, we've collected more than 20,000 responses from all over the world, from all different industries, including very highly regulated industries. So we're very confident. I mean, they exceed the factor of results you'll need to demonstrate statistical significance by a factor of 100. So we're like 2 orders of magnitude higher than the number of responses you need that are regularly used to do surveys in science. I mean, if you go and look at scientific journals, you will see all the time people publishing papers where N sample size is less than 100. We do not have that problem. We have 20,000 responses from all over the world from different domains. So while the number of people, we would expect the vast majority of people to be low performance. That's not true. We actually have quite a lot of people in the high performance group. So that's what tells us that there's some level of availability, selection bias. But we are very cleanly able to divide people into low, medium, and high. And so even though there's selection bias, you can still say very strongly that the results are statistically significant and valid.
So in your slide with the things that fed into organisational health and happiness, it didn't look like there was anything about resourcing in there, so having enough people to do all the things that need to happen.
Yep.
Was that something you considered or
No, and actually I think the important thing is, my hypothesis, which again we haven't asked this year, but good to have things for next year, is that it's when people split time between different projects. That I think is probably going to be the thing that predicts this problem. So yeah, we didn't ask that this year, but I'll make a note of that for next year. And just in general, like, feel free to ping me and Nicole with your ideas. We're always happy to get new ideas. But I suspect that would be it, when people are dividing their time between multiple different projects, because that, I think, is probably what kills things. But that's just me saying that. There's no data. Thank you very much.
Thank you, Jez.